What is a linked list? A linked list is a linear data structure. It is a linear data structure which has two parts, data and the link. The data which is stored as in nodes and the link which is containing to the other node. Each node contains data and the link. Uh, Usually, the in the arrays, the memory is not contagious. Size can grow and shrink dynamically. The structure of the node is like this. How structure of the node is like data and the link. This is the singly linked list. Singly linked list, data and the link. Here, the representation is in the Java. We are defining the class as a node and in declaring the data as an integer and node is equal to next. The node as a int data, the pointing to this pointer you are using, this dot data is equal to data, points to the data is points to data, and this next is points to null. This is the representation. How linked list looks like? The linked list looks like head and the tail. Center is the nodes which have connected. The first head is the first node and the tail is the last node. Null is the end of the list. It's like the linked list as represented. And types of linked list. Singly linked list. Singly linked list means we have nodes point to point, nodes next to next. This like is called as singly linked list. As a representation as shown like this: 10 to 20, 20 to 30, and null. Then doubly linked list. What is mean by doubly linked list? Doubly linked list as look like this, which has previous and the next node. Each node has a previous and the next node. The null values can be starting point or the ending point. And the third one is circular linked list. The circular linked list is nothing but the last nodes are pointing to the first node. This is called as circular linked list. The basic operations. Traversal, the printing all the elements. We want to print all the elements means we define it as print list, node as defined as head node, and node temporary is equal to temporary as head, and the loop we are using while loop. Temporary is not equal to null, the head node is not equal to null, system dot printer plus the nodes will continues. Temporary is equal to temp dot next, the next node will be printed. The loop will runs automatically. And next operation, insertion. How we can insert a node? We are creating the defining the node. New node is equal to new node of node number of 5 nodes. New node dot next is equal to head is equal to new node. Like we are inserting. Insert at the end. How we can insert at the end? We are defining the node new node is equal to new node 40, number is 40. The temporary as we are defining the head as a temporary, while loop temporary dot next is not equal to null, it will be pointed to next and insertion will be takes place. Delete it. How we can delete the first node? Head is equal to head dot next. This like we can delete. Deleting the last node. We are defining the head as a temporary node, and while not equal temporary node is not equal to null and temporary next, and after the loop temporary dot next is equal to null. And here next we will see the comparison, linked list versus array. Memory is in the arrays, the memory was a contiguous and the linked list non-contiguous, and size was fixed in the array. Linked list there is no dynamically size was arranged. Insertion is costly, in linked list it was an easy. Deletion costly, in the array so it was deletion is costly, and linked list it was easy. Axis of the time complexity was big O of 1, big O of n. This was the time complexity. To access big O of n, insertion big O of 1, insert at the end, big O of n, delete at the end. These are the concept of linked list for the today's second problem of the linked list series.